In just 60 seconds, a small fire in an enclosed space can turn into a hellscape with temperatures exceeding 1,800 degrees Fahrenheit. Toxic smoke spreads faster than flames, oxygen is rapidly depleted, and humans are left with almost no time to react. In many situations, firefighters cannot even reach the scene because in some places, a single misstep can lead to the worst possible outcome. But engineers around the world have prepared for the worst-case scenario. They have developed technologies designed to go where humans cannot. Heat-resistant robots, firefighting drones operating hundreds of feet above the ground, and fire suppression systems that use only a few liters of water, yet can collapse an entire inferno. In today's video, Mandarin Tech takes you inside the world's most advanced firefighting technologies. The final line of defense standing between fire and catastrophe, where every second determines survival. Hydraulic submersible pump. Hydraulic submersible pumps are manufactured on a global scale, with the most advanced firefighting designs primarily originating from the United States and Europe. When mounted on specialized vehicles and integrated into large-scale firefighting systems, a hydraulic submersible pump functions as a highly reliable mobile water source. Unlike electric pumps or surface-mounted diesel pumps, the entire pump head operates in a submerged state, while power is transmitted remotely through high-pressure hydraulic hoses connected to the vehicle-mounted power unit. This design eliminates the risk of electrical short circuits, sparks, and mechanical damage in hazardous environments. In real-world operations, when fire engines or rescue vehicles arrive at the scene, operators only need to lower the pump head into static water sources such as rivers, lakes, canals, flooded pits, or natural reservoirs. Hydraulic oil from the vehicle transmits torque directly to the impeller assembly, generating large and stable flow rates that immediately supply water to monitors, foam firefighting systems, or booster hose lines. Thanks to this mechanism, the pump requires no priming, does not rely on the electrical grid, and can operate continuously in conditions involving mud, sand, and debris. The system's key strengths are rapid deployment, the ability to access distant water sources, and a high level of safety in flammable and explosive environments, particularly in industrial zones, fuel storage facilities, seaports, and areas far from urban water supply systems. Firefighting system in Kayabuki no Sato. Kayabuki no Sato is a small village located near Kyoto, Japan, famous for its more than 40 traditional historic houses with thatched roofs. However, thatched roofs also mean an extremely high risk of fire. Local officials recognized this in 2000, when a major fire destroyed the village's central storage facility. In addition to urging residents to remain constantly vigilant, local authorities decided to install a special water sprinkler system capable of watering the entire village in the event of a fire. This system is tested regularly twice a year, usually in May and December. During these test events, visitors from all over flock to Kayabuki no Sato to witness the spectacle of numerous massive water sprinklers operating simultaneously. To preserve the village's traditional appearance, 62 metal water pumps are concealed inside small, wooden structures designed to look exactly like real houses. When the system is activated, the roofs of these houses open up, allowing the water cannons inside to shoot powerful streams of water high into the sky. The testing of the sprinkler system has become such a special occasion that it is known as the Kayabuki no Sato Water Sprinkler Festival. Dozens of sprinklers operating at once create a spectacular scene, especially on sunny days when the water streams form shimmering rainbows over the thatched rooftops. Fire blanket. Without the need for water pressure or chemical agents, fire blankets extinguish flames using the most fundamental principle of fire: oxygen removal. This is not merely a piece of fabric thrown over a fire, but the result of carefully engineered, passive fire-resistant material design. The fire blanket's exceptional heat resistance comes from its inorganic fiber structure, typically made from heat-resistant fiberglass or specialized mineral fibers. Unlike organic fibers, these materials do not burn, do not melt, and maintain structural stability even when exposed directly to temperatures reaching several hundred degrees Fahrenheit for short periods of time. The core technology behind a fire blanket lies in its oxygen cutoff mechanism. Fire cannot exist without oxygen, and fire blankets are designed to create an airtight barrier that severely limits air from entering the burning zone. When deployed correctly, the blanket presses tightly against the burning surface, rapidly reducing oxygen concentration and causing the combustion process to become gradually smothered until it is fully extinguished. At the same time, the blanket's dense woven structure helps contain smoke and toxic gases, reducing the spread of heat into the surrounding environment. In strong wind conditions, fire blankets can be secured using ropes or fastening straps around a vehicle. After use, the blanket can be folded along predefined creases, rolled up, and secured, ready for the next deployment. EmiControls. EmiControls is a technology company from Italy, specializing in the development of remote-controlled firefighting robotic systems designed to operate in environments that are almost impossible for humans to access safely. EmiControls firefighting robots typically use a tracked chassis, allowing them to move flexibly across a wide range of terrains, including slippery surfaces, flooded ground, debris fields, and confined spaces. This drivetrain is particularly well suited for tunnels, narrow corridors, subway stations, warehouses, airports, and heavy industrial facilities. Mounted on the robot platform, EmiControls integrates a turbine-based water or firefighting foam spraying system combined with high-pressure fans. This configuration allows the robot to both suppress flames directly and generate powerful airflow to push smoke, toxic gases, and heat away from the fire zone. The spray system can produce a high-volume water mist, rapidly cooling the surrounding environment, reducing radiant heat and limiting fire spread. In real-world deployments, EmiControls robots are often used as a vanguard force. They advance ahead of firefighters to reduce temperatures, clear smoke, and bring the fire under initial control, thereby opening a safe access corridor for firefighting crews to move deeper into the scene. This combination of remote operation, high durability, and multi-role fire suppression capability has made EmiControls robotic systems an important component of modern firefighting strategies, where human safety is always the top priority. Ifex Shotgun. Since 1994, firefighters in Germany have been using a fire extinguishing gun known as Ifex, short for Impulse Fire Extinguishing System. The Ifex Shotgun has since become one of the most unique personal fire suppression systems ever deployed in modern firefighting. During operations, firefighters can carry the Ifex directly on their body. The system consists of two stainless steel cylinders, one containing compressed gas at a pressure of approximately 360-435 psi, and the other containing water or a firefighting agent. The two cylinders are connected by an ultra-fast release valve with an opening time of only about 20 milliseconds. This extremely short opening time allows energy to be released almost instantaneously. The greatest advantage of Ifex lies in its exceptional effectiveness using very small amounts of water. When combined with firefighting foam, the system is also capable of handling oil and chemical fires. According to Ifex Fire Suppression Systems, this technology has now been deployed in dozens of countries worldwide as a high-speed fire suppression solution for emergency situations in enclosed spaces. Firefighting drones. When fires break out at great heights in areas that aerial ladder trucks and ground crews struggle to reach, firefighting drones begin to emerge as an entirely new response line. The Chinese company Ehang has adapted its passenger-carrying aerial taxi platform into a multi-role firefighting drone. This system is primarily intended for high-rise building fires, where deploying firefighters using traditional equipment is both slow and dangerous. The Ehang drone is equipped with a foam tank holding approximately 40 gallons, along with a high-pressure water nozzle mounted above the cabin area. It uses a camera system and laser targeting to achieve precise aiming. The drone is designed for semi-autonomous operation, capable of flying automatically from the fire station to the incident site, while the firefighting process itself is controlled by an operator. According to EHang, the drone can address fires at heights of up to approximately 2,000 feet, within a radius of about 3 miles from its launch station. In contrast to drones that create immediate impact using firefighting projectiles, some systems focus on the ability to suppress fires continuously from above. The Skytech S300 is a heavy-lift drone with a maximum payload capacity of approximately 330 pounds. This capacity allows the drone to carry a spray nozzle system, supply hoses, and flight stabilization equipment, while maintaining stable operation at significant heights. The drone has a standard flight time of approximately 40 minutes, which under optimal conditions can be extended to nearly 50 minutes, sufficient to reach the scene, hover steadily, and conduct continuous firefighting operations. In terms of operational capability, the Skytech S300 can operate at heights of up to approximately 1,600 feet, making it suitable for fires in high-rise residential buildings, office towers, and dense urban areas. Rather than carrying a limited onboard water supply, the drone is designed to connect directly to a ground-based water source, such as a fire engine or hydrant, via a high-pressure, flexible hose system. RXR MC-A2BD. The RXR MC-A2BD is a firefighting robot designed with a fully explosion and fire-resistant structure, allowing it to operate safely in environments with extreme heat, dense smoke, and explosion hazards. Its tracked chassis enables stable movement across slippery surfaces, flooded ground, and debris-filled areas. A battery-powered system combined with a shock absorption mechanism protects internal components and maintains operational stability under harsh conditions. The robot is equipped with a high-capacity water cannon capable of continuous discharge at a pressure of approximately 145 psi, with a maximum spray range of up to 230 feet and a wide 120-degree spray angle, allowing fires to be suppressed from a safe distance. The spraying system also provides three-dimensional cooling, helping to reduce heat buildup on the robot itself when operating close to fire sources. In addition, the robot can detect up to 8 types of toxic and hazardous gases, supporting rapid on-site risk assessment. Safety features include automatic obstacle avoidance, guiding lights, and audible and visual warning systems. In terms of operation, the robot reaches a speed of approximately 3.6 miles per hour with a pulling force of about 1,150 pounds force, allowing it to tow large-diameter fire hoses, climb slopes, and overcome elevated obstacles. Its remote control and video transmission range extends up to 3,280 feet, and an emergency stop function further enables the RXR MC-A2BD to serve as an effective firefighting tool in the most hazardous situations. Elide Fireball. Elide Fireball is a compact yet highly effective passive fire suppression solution designed to self-activate upon contact with flames. When exposed to fire, the ball triggers a mild explosion after a few seconds, dispersing fire-extinguishing powder in all directions, rapidly suppressing the fire at its earliest stage. What makes the Elide Fireball unique is that it requires no electrical power, no human activation, and can operate even in the absence of firefighting personnel. Within a radius of approximately 13 to 16 feet, the powder blankets the fire source, cuts off oxygen, and inhibits the combustion reaction, helping extinguish flames early. At the same time, the ball emits a loud warning sound, serving as an alert that prompts people nearby to quickly move away from the hazardous area. Fire never gives warning. It emerges from the smallest faults, in the most ordinary moments, and then spreads faster than human reaction time. That is why what truly matters is not how well we extinguish fires, but how early we prepare for the worst. The devices and systems you have just seen do not always make headlines. They operate behind walls, high above ground, or deep inside tunnels. When everything functions as intended, almost no one notices their existence. But when an incident occurs, they become the fragile line between control and catastrophe. Mandarin Tech believes that behind every machine and every system lies a very real story of preparation, of worst-case scenarios that humans are forced to anticipate in order to protect themselves. If you find these stories worth exploring further, please like, subscribe, and turn on notifications to continue this journey with Mandarin Tech in future videos.